Hello everyone, welcome to the Maths Club. So today we are going to find out the volume of solid formed by rotating a region bounded between two curves about the y-axis. But this times it will going to be a little bit different. Here we are going to use the cylindrical or shell method. And also we are going to discuss why we are using the cylindrical or shell method rather than disc or washer method. So let's again start with an example to make the things clearly understandable. This is the question. Find the volume of solid formed by rotating a region bounded between the curves y is equal to sin x and x axis from x is equal to 0 to x is equal to pi by 2. And this region is rotated about y axis. So like before, first we will identify the region and then we are going to rotate this region about y axis to get the solid. Then first we are going to check is disc method is applicable or not. If not, then we are going to go for the cylindrical or shell method. So this is the curve of y is equal to sin x from x is equal to 0 to x is equal to pi. This is the peak point of the curve at pi by 2 where y is equal to 1. So this portion is the bounded region by the curve and the x-axis. So let's shade this portion. Now this region is rotated about the y-axis to create the solid. To create the solid, we need to draw the image of this curve about the axis of rotation. Here axis of rotation is y-axis. So we need to draw the image of this region about the y-axis. So first, the image of the curve y is equal to sin x about the y-axis. Now we have to complete the solid of rotation. For that, we need to draw circle at both ends of the curve. So this is the circular part or circular top and this is the circular bottom. So let's shade the rest of the part to complete the solid first. So this is the solid we got. Now according to the disc method, we need to draw or we need to take the cross sections of this solid perpendicular to the axis of rotation. Here the axis of rotation is y-axis. So we need to take the cross section of this solid perpendicular to the y-axis. So we will get two different circles for the cross sectional part. This is the inner circle and this is the outer circle. Let's shade these portions of the circle to complete the disc. So this is the circular disc so formed. Here we can see the inner radius of this circular disc is this part and outer radius is from this point to this point. To use the disc or circular method, we need to find out the volume of this disc and you have to integrate it. Now, to find out the volume, we need the area of this disc. But here you can see both the inner radius, small r, and the outer radius, that is capital R, is coming from the same curve y is equal to sin x. So as the inner circle and outer circle both bounded by the same curve y is equal to sin x, so it will be very difficult to distinguish between the smaller and the capital R, because both will ultimately the x values from the same curve y is equal to sin x. So to distinguish the smaller and capital R, we have to take some range of the values for the x and you have to use that value, which will not going to be very easy things to do. And in fact, it will be very complicated. So whenever this type of situation arises, that is in the disk method, distinguishing both the R are difficult or both the R comes from the same curve, then it is better to avoid the disk or washer method. So that's why we're going to use the cylindrical or cell method to find out the volume of the solid. As the disk method is not applicable here, so we're going to use the cylindrical or cell method. Now, according to the cylindrical or cell method, first we need to draw a cylinder whose axis will coincide with the axis of rotation. So let's draw a cylinder whose axis is coinciding with the axis of rotation, that is the y-axis. Let's shade the cylinder also to better understanding. So this is our required cylinder. Now, first we need to find out the surface area of the cylinder, the dark green part. Because when we will move this cylinder from this point, that is x equal to 0 to x equal to pi, this will going to cover the entire solid. So if we integrate the volume of the cylinder so formed from x equal to 0 to x equal to pi, then that will going to give us the volume of the entire solid. And volume of the cylinder can be find out by multiplying its curved surface area with its width. So for curved surface area, we need the radius and height of the cylinder. So this is the height of the cylinder, and we can see as the height is actually the distance from the x-axis. So the y coordinate of this point will give you the height of the cylinder, and this is the radius of the cylinder, and as the radius is the distance from the y-axis, so x coordinate of this point will give you the radius of the cylinder. So these are height and radius of the cylinder. So now here we can conclude that curved surface area of the cylinder which you can denote it by delta A is equal to 2 pi r h. By substituting h as y and r as x, it's become 2 pi x y. It is better to convert the area into a single variable terms, and as this xy denoting this point which is lying on this curve y is equal to sin x, we can simply replace the y by the sin x. So 2 pi x into sin x. This is the curved surface area of the cylinder. Now if we look at the width of the cylinder, here is the width. You can take the width as any portion which is parallel to the x-axis. In any end, we can take the width. And as the width is parallel to the x-axis, so width can be taken as delta x. So finally, we can conclude volume of cylinder delta V is equal to area, that is delta A, multiplied by the width, that is delta X. So that finally gives us 2 pi x sin x into delta x. And here you can see the x is varying from 0 to pi. So to get the volume of the entire solid, we need to integrate it from x equal to 0 to x equal to pi. For better understanding, we will get rid of all the shaded part of the solid such that the cylinder is clearly visible, and we can easily understand how the relation between the radius, height of the cylinder and x and y of the point came. So here is the solid so formed after eliminating all the shaded region. This is the cylinder which is formed by taking the axis of the cylinder coinciding with the axis of rotation, that is the y-axis here. This is the radius of the cylinder and this is the height of the cylinder. We already found out the volume of the cylinder delta V is equal to 2 pi x sin x into delta x, where x is varying from 0 to pi. Now to find the volume of the solid, we need to integrate the volume of the cylinder from 0 to pi. The volume of the solid V is equal to integration of 0 to pi delta V. We have to replace the delta V, and of course like before we have to replace this delta x by the dx. So it comes as 2 pi x sin x dx. 2 pi is the constant terms, so we can take the 2 pi outside the integral. It finally gives us 0 to pi x sin x into dx. Here inside the integral we have two different functions. One is the algebraic function x, another is the trigonometrical function sin x. So here we have to use the integration by parts formula to find out the value of the integration, that is the value of the volume for the solid. So here we have to use the integration by parts, and according to the integration by parts, if u and v are two function of x, it can be written as u into integration of v minus differentiation of u, integration of v, and the whole integrations. The v should be a function whose integrations can be done comparatively easily and whose integrations will give a comparatively simpler values. Here the integration we have is volume v is equal to 2 pi 0 to pi x sin x dx. We can consider the x as u and the sin x as v, because the differentiation of x will give you 1 and the integration of sin x will give you cos x. So the second part will become comparatively easier. After applying integration by parts, the integration become 2 pi x into integration of sin x dx minus differentiation of x into integration of sin x dx and the whole integrations. Rather than taking the limit individually, we can take the limit for the entire functions together. So after doing the integrations, we're going to get 2 pi x into integration of sin x is minus cos x. Here the differentiation of x is 1 into integration of sin x is minus cos x dx, and the limit is 0 to pi. Finally, after simplification and integration, so we're going to get 2 pi, this gives minus x cos x. Here the minus will come out to become plus, and integration of cos x is sin x. At the limit we have 0 to pi. Now just need to put the values of upper limit and lower limit. So 2 pi remain outside. The upper limit is pi. So it is minus pi cos pi plus sin pi, and at 0 this is 0 as well as sin 0 is also 0. Now put the value 2 pi. Here it is minus pi, cos pi is minus 1, sin pi is 0. So after calculating all, we are getting the value of the integration as 2 pi squared. So we can conclude the volume of the solid so formed is equal to 2 pi squared. So hope you understand the process. In the next video, we will going to discuss a more complicated questions regarding the cylindrical or cell method. So stay tuned for that. Thanks for today. Have a nice day.